Okay, my name's Ashley. I'll be doing a little demonstration of a project I've been working on. Just to preface this, I am sorry for any hissing in the background. I realised after starting this recording, well actually beforehand, that I probably need a DAC because my mic's auxiliary port is picking up all kinds of weird electrical interference. So definitely need a DAC. We'll invest in that. Anyways, I've been working on a little project called ProtonDB Lookup. Admittedly, by working on, I mean I started about 5 hours ago and spent a few hours on it and yeah, finished it all up and whatnot. Hold up. So, the reason this project exists is a little site known as ProtonDB. ProtonDB is pretty interesting. See, I run primarily on Linux, Arch Linux specifically with the Zen kernel, running version of the kernel, oh wait, it's already there, 6.0.10. Figured I may as well preface it with that. Anyways, I run mostly Linux. Linux gaming is quite interesting at the moment. We have a compatibility layer known as Proton. It uses Wine, where it's a fork of Wine. Wine is another compatibility layer that helps us to run Windows applications. Proton specifically designed to run Windows games. Now, Proton works pretty well out of the box, even with some anti-cheat. EAC, or Easy Anti-Cheat, starting to get there slowly. Battlei's pretty much complete. That just works across the board almost, with maybe a couple notable exceptions here and there. But the issue I run into is anytime I want to check, hey, is a game compatible with Linux? You know, I've got to go open up a web browser, go to ProtonDB, then I've got to search for like Borderlands 2, I've got to go here, and you know, I've got to do all that glorious stuff, go, oh look, it's native, oh wait, that's not 100% what I want, but yeah, Borderlands 2 is native. See, that's the thing, it shows native there, but then it shows gold there, very weird. It's like, yeah, it runs perfectly after tweaks, and it's like, yeah, it's native, it runs well, mate, come on. I do find that annoying. I think they should probably have gold up there, because the native implementation of Borderlands 2 is completely dreadful. It's really bad, from what I last tried of it. So I just run it off Proton these days. But yeah, if we, for instance, go here, we'd see gold. But yeah, that's interesting. That gives us one bit of information. But there's a bit more hidden information going on here that you won't necessarily be able to just see on the front here. So I was like, hey, let me create an application that allows me to very quickly search for what's on ProtonDB. So I did. That application is called ProtonDB Lookup, as we can see. And if I go ahead and run cargo run, that will go ahead and compile it and then run the application for us. And here we can see that we can input a game name. So we'll go with the Borderlands example again. And I do need to create some user feedback here, I'm not going to lie. I realized that when my brother tried running this, he was like, oh, has it hung? No, it really hasn't. It's just loading. Give it a sec. See, the way this software works, actually I'll get into that in a minute. But anyways, we have pulled a list of games for us to search for, right? So which Borderlands were we on about? Well, we'll say Borderlands 2. So we click that, and boom, we get our ProtonDB information. This is the name of the game, this is the app ID associated with Steam and their database of games. This is the best reported tier, which is Platinum, a far cry from Native, I will admit. Native would imply that it works flawlessly. Platinum does also imply that to an extent. Some Platinum games, I would admit, lie. The current tier at the moment is Gold, which is accurate, and the trending tier seems to be going more towards Platinum. So it seems like it was Gold, but more and more people are going towards Platinum now. So that probably means that it's pretty good. We can even see the total amount of user reviews, so we can get an idea if it's accurate. We even get a ProtonDB score and a confidence as well from ProtonDB, which is something you don't get to see. So I was like, oh, that's pretty cool. We have a bit more background information, very useful. Admittedly, there is one thing that's kind of annoying. You know, if we go for like something like Monster Hunter, that is a pretty big franchise. It takes a while to get through all these games. And the thing is, we're not just looking for games, we're also looking for DLC. And we have to then remove it from the list, so that takes a bit longer to do. See, like we got 4 results back. I don't know, we'll do number 2 there. And boom, yeah, Monster Hunter Stories 2, Wings of Ruin, Platinum. Admittedly, only 22 user reviews and the confidence isn't particularly strong, so that might be inaccurate, who knows. It might have gotten worse over time. Quite frankly, hard to tell. Anyways, so, pretty cool little application. You're probably wondering, how does it work exactly? Well, it's pretty straightforward. Oh yeah, I don't have actually anything. I should probably have some information on him. Yeah, ignore this page for now. This will be updated probably tomorrow with a bit more information on exactly how this program works. Definitely with this YouTube video as well, showing it off. So anyways, it's pretty basic how it works. We go to our main function. I'm going to try and take you through it step by step. So we clear the screen. The clear screen function, by the way, this software is cross-compatible with Windows to a point. If you try to run it through command prompt, this clear screen function... Oh, I thought someone was knocking at the door. It was a bloody cat on the stool. Scared the crap out of me. Bertie, you sod. Alright, anyways, yeah, this clear screen function just doesn't work on command prompt. I'm not 100% certain why. I just have to say command prompt is an archaic mess, and you should probably switch to Windows Terminal or PowerShell. From what I gauge, Windows Terminal definitely works. PowerShell I didn't test, but I have no reason to believe why it wouldn't work, because PowerShell's pretty competent. So, definitely use those if you're on Windows, although I don't know why you would be using this software on Windows, but the option's available to you in case you're dual booting and just wanted to quickly check out a ProtonDB information on Windows. It's there. You may check it out. Anyways, simple function for clearing the screen. Our next step is to pull the game name. We want to grab that from the user, so just a simple, read line. We get the line from standard input, which is, where we had, I can just demonstrate it down here. Standard input, which is this here, right? When we're typing, we'd have that, Borderlands again, that's standard input, right? We read that line, and boom, that's what we get. Yeah, this bit here, we're printing to a line, but we're not going to print line. If we did print line, that would essentially do a line break, like a /n or a /r. We don't want to do that, right? We don't want a line break. Oh wait, what the? Oh right, my bad. Yeah, that's it's Copilot getting in the way a bit there. Just recently reactivated that again, so wasn't too used to it. But anyways, yeah, we don't want to do print line because then it'll do a line break. We don't want that. We want this little essentially command prompt indicator on the same line. So what we do is we just print to the line, but that's not enough. Print doesn't flush standard out. So what we have to do then is create a temporary variable, a dispose essentially, using underscore, and we just call standard out and we flush standard out. Standard output, if you're into programming, you know what that is. Standard output outputs to a terminal, or just outputs in general, right, to standard out, which then means an application can listen to standard out and grab the information from that. Standard in is, the user inputting data. Standard out is the application outputting data. It's essentially all it is, right? So we flush standard out, and then that essentially tells Rust, oh hey, let me push that to the terminal. Although I don't think it specifically tells Rust, I think the terminal grabs that itself. Not 100% certain how that works under the hood. Anyways, so we standard in, we read the input, clear screen again, print this, garbage, honestly I might have to get rid of this. It's pretty ugly. I won't get rid of it yet though. Anyways, so we clear the screen, we print that, and then we essentially grab our game name again. Oh wow, did I really do that? That game name from string at game name. I guess because, yeah, it's been wrapped. That's it? Yeah, from stir. What? Is that needed? I'm going to have to look into that. I feel like that might not be needed. I'm still relatively new to Rust. I've been using this for like 2 weeks. I'm looking at it now and I'm doubting myself. Especially considering I've used let game name twice. That feels ugly to me. I might have to change that. Anyways, moving on. We essentially unwrap our game name because it is wrapped up. I believe when it goes through standard in, yeah, when we do a read line, we get a result. Oh no, you actually do edit game name. Wait, what the fuck? Oh, sorry for swearing there, but what type is it then? It says it's type string, but that's obviously from where I instantiated out there. Is that even needed? 2 secs. If I just did that, it works fine, right? If I just do that? Yeah, I'm doubting myself here. Let me try and run that a sec. I'm well confused. Why did I do that? I must have had a funny 5 minutes there, because that feels unnecessary to me. Right? Terribly sorry about this. I'm very new to it, so I see that unnecessary line. I'm like, I must quickly test that, because that feels useless. That was useless. I don't know why I did that. Okay, so that was a pointless unwrapping. We're going to completely ignore that. That's going to be removed from the project. I won't bother updating the version number on the actual like application. I mean, I could do. Yeah, I will update it. It's a minor patch, I suppose. I'll have to include a couple other things with that minor patch as well. I'm just going to do that. But anyways, yeah, that will be removed in the future release. I'll probably do that before I go to bed tonight, considering it's like 20 past 2. Anyways, so what we essentially do is we're going to ignore that. We're going to be getting a games list. Now, this games list is going to be using my function getGames, and it takes a reference to a string, which would be our game name that the user chose, and then we unwrap this games list. Admittedly, kind of bad code. I should probably check for errors on that, but I haven't. Once again, we'll update that with some proper error checking. Anyways, for now, it just unwraps and hopes there's not an error. If there's an error, it will panic and crash. So definitely need to fix that. Moving on. Our getGames function takes game name, and once again, it is a reference to a string. What is that? String literal, isn't it? Or is that str? Ooh. You can create a string from a literal string with string from. Oh, yeah, no, string literal is the little lowercase str. This is a non-literal string. It's a growable string, as it were. You can add to a literal string. You cannot add to. It is essentially constant, unmutable. If you want to add to a string, you have to convert it into a growable string, and then you can push data to it. Anyways, yeah, this is essentially what we're going to be doing here. Anyways, first off, game name returns a result. A result essentially allows us to get an error or a result from it, which our result is a vector of vectors of strings. Bit messy. Probably the best way I can think to do it in Rust right now, unless there is a simpler solution instead of having 2 vectors within each other. But that is feel like the simplest solution right now, and probably the better one. And it also has a box, a dynamic error. I can't remember what the box structure is anymore. I know it's a struct. Pointer type for heap allocation. Oh, okay, right. So we just allocate data to the heap. Fair enough. So yeah, this is where we'd allocate our error to the heap. If we did error out, assuming it never got to the OK at the bottom here, if it somehow fails before then, it will error out and give us an error that we can then read from and figure out if it worked or not, pretty much. Anyways, moving on. The wonders of a result. It's a great little thing. I do love the error detection and error catching in Rust. It's very good, very streamlined. It definitely feels a lot cleaner than Python, I'll give it that much. Anyways, moving on. Here we create a URL. We get it from a string literal, being this. So this is the direct search page for Steam. If I go ahead and demonstrate that over here. Yep, see, if we provide nothing, it just literally looks for games. Literally, yeah, any of them. 123,000 games, apparently. Based on, oh, okay, they exclude games based on preferences. I'm not even logged in. How the hell's that happened? Alright, fair enough then. But either way, yeah, we're making a simple call to store.steampowered.com, and we're using the search function here, and we are providing a variable called term. And there we will add the game name to said term. So if it was Borderlands, we would essentially just be doing that, and that would give us the search for Borderlands, right? Oh wow, that's a good price for Borderlands 3 actually. And Borderlands 2. If you ain't snatched up Borderlands 2, get it for £5. Very good game. Although, preferably, get the Game of the Year edition, which admittedly is a I actually don't know how much it is. You'd have to look. But anyways, get the Game of the Year edition. It's well worth it. Borderlands 2 base is alright, but that DLC just fine. Anyways, so after adding game name to it, we essentially get this returned back to us. Very neat. So what do we do with this data? It looks almost useless to us, surely, right? You know, what use could this possibly provide? Well, if we come down here, this is just building out a client to make the HTTP GET request. This does the HTTP GET request, right? Fairly basic. Pass the URL through, send the GET request, and then return the GET request as a string. You know, get the response as a string essentially, or as text, as it calls it. And then what we would do is we would essentially take that res and then do it as text there, or as string. But anyways, yeah. Next step we do is we need to parse HTML data. I'm using Scraper for that. Scraper is very good. I'm using Reqwest as well, by the way, for the HTTP parsing, and JSON for any JSON-based shenanigans. We'll be getting around to that later, don't worry. So anyways, we create another variable to store our HTML parser, and we pass through the document of this. I like how it calls it document. It's not. It just passes a string of HTML as a document, quote unquote, you know. But yeah, it just gets a string of HTML, so we pass it that because that's what we get back as a response from the server, is we get a string of HTML. I can actually demonstrate that right now. If we go into the network here, I hit refresh. Don't need XHR. My bad. We get this back, right? This is our headers. This is essentially the GET request that we built in Rust, but visualized here. That's the term, you know, the file name, which is search. Search is a file. Essentially some sort of script file, might be Python, might even be Rust, who knows, right? Could be some WebAssembly, like written in C++ or whatever. Could be anything. Anyways, what we get back is a response. And we get back this as a response. Or the raw HTML rather. We don't get back this pretty little visualization of the HTML. No. We get the whole raw data, right? The whole lot. So fun. Don't need XHR. XHR is like API calls and stuff like that. We'll get into that, don't worry. Although I will admit I did cheat. One of the API calls I used I had to Google for. I couldn't find it to save my life. Found it on Google though. Well worth the search. It saved me so much headache and so much time. Google is your friend a lot of the time when dealing with stuff like this. Anyways, then we get a selector. This is also from the Scraper software, or say software, Crate rather, which if you didn't know, Crate in Rust is just a library or a package. If you're used to Python, it's essentially just a package, which allows us to extend the functionality of Rust. Anyways, here we're going to essentially set up a parser. We are specifically looking for the the R hash stuff here is so we can have the quotes here, pretty much. It allows for that kind of thing instead of having to do like the whole wonky breaks and stuff like that. We don't need that. That's redundant. We can just do R and hash and then a string literal in between the hashes, and that works nicely. Anyways, what we're looking for is we're looking for an A tag. So for example, if we come over here and we go ahead and inspect this, we'll notice that each of these rows is essentially an A tag. An A tag is known as an anchor tag in HTML. It's essentially just a link. You know, if we click on this, I did control click there, but if you click on it regularly, you'll be taken to this page, right? Nice and simple, right? So this is interesting. This A tag or anchor tag stores some intriguing little information for us. Specifically, if we go back here, it stores something known as this class, the search result role, DS collapse flag, right? The name. The end bit here is probably just styling, honestly, but here is what we're interested in. It's part of the search result role. It is a row of search results, right? So, useful. We're going to find all those. All of them should be all of this down here, right? Not the stuff that's loading in now, that's extra content, just the stuff that loaded in initially, right? From, if I go back to the response here, if I scroll down, all this stuff, right? From the top to the bottom, this is all that gets loaded in. Because that's all we need, right? If we're looking for a game, it's probably not going to be on page like 4, right? It's going to be at the top. Steam's pretty damn good with the searching. So anyways, we only take the first page, that's all we need. So we look for all the search results, and we go ahead and create a selector for that. We'll be using that later, don't worry. Then we create a mutable variable. A mutable variable means that we can edit it, and that's going to be our vector that stores a vector of strings. That's essentially going to be the information about the games. I'll get into that, what that is, and we just create an empty vector here, a new empty vector. Now we get to iterate through all the elements in the document that match our selector. The selector is back up here again, right? Yeah, this stuff. So we're going to iterate through every element that's in the document that matches the pattern of this selector, okay? Being the A tag with that class in it, right? If we find something that matches that pattern, that is an element, so we're going to go ahead and look into that element a bit, and that's what we're doing here. When we find that element in that list, we're like, okay, let's do some stuff with it. So first off, we're going to get the wrapped app ID. This is very useful to have the app ID wrapped first in that option. Option's essentially like a result, except it works a bit different. Option can't do errors, but it can do none and some. So if something's none, it means we didn't get any info. If it's some, it means we got something, right? So all we're doing is we're looking at the element, we're getting its value, we're getting a value, and that value will be an attribute, and that attribute is known as data ds app ID. So the interesting thing about these is in the A tag here, we see if we come over here, it stores the app ID within the A tag. Very, very useful. It really didn't need to do that. It probably could have gotten away with just having the web link and then passing the app ID from that, but it didn't. Right? It has it also stored in the HTML here as a nice little attribute, right, to the HTML element here. So that's very handy for us. It makes it so much easier for us to get the app ID. Otherwise, we would be passing it from the href here, would be splitting it via all these slashes, essentially, until we got to this particular part. We know it would be pretty consistent. You know, we would have the 0, and then 1 would be between those two, and then 2 would be here, and then the third part of that split would be there, and then the fourth part would be there. So we'd look at the fourth part of the split and go, okay, that's where we do it, right? Or fourth index of the split. Boom, we just grab that information. But we don't need to do that. Thankfully, it's stored in an attribute. Very handy. So we just grab that attribute. It's wrapped in an option. We check if it's none. If it is, then we continue, right? Clearly that element, yeah, it doesn't have that attribute, so we must have gotten the wrong element somehow, right? Just in case that happens, we just continue and move on to the next element. Then, after we've confirmed that it is correct and we have got the right, at least as far as we're aware, the right content, we will then go ahead and unwrap that app ID so we can actually use it as a string literal here. Once again, not changing, so it is a string literal because it's constant. And then we also check if it contains a comma, because I did see an instance, I don't know if I can find it down here, very easily at least. This entire thing is just awful to read, it hurts my brain. But I did find an instance where essentially we would have, 26 or whatever app ID, then another app ID, then another app ID, right? And that wasn't good. I'm assuming what that is like a bundle of DLC, so it has multiple app IDs associated with it. We don't need that. It's pointless. DLC doesn't come up on ProtonDB anyways, so it's kind of redundant information. So if we find commas in it, clearly we've got redundant information, so we're going to ignore it completely and just move on to the next element. Going back down here, we then need to find the title. Now the title, unfortunately, as far as I could see, does not exist within our glorious attributes up here. Technically it does. It exists there, but it has like an underscore and stuff. It's not formatted very nicely. So I was like, okay, I want a better way to format this. So I looked through the A tag, and we can see that there is, indeed, if we go to our selector up here, a span that has the class of title. If we come over to here, there it is, span of the class of title. Really weird spaces, I don't like that. Oh, okay, that cleared it. But either way, oh, I see, it's just when I click on it, it has that weird space sometimes. Okay, very weird. Don't like it. Right, anyways. This span has the class of title, and it's Borderlands 3. Okay? All of these games, have that glorious little span, right? There it is, Borderlands 2 one, and pre-SQL also has it as well. So very useful. We can get the title of the game. So we go ahead and we grab the selector of that, and then we look at the element, and we find any elements within that element that matches the pattern of our title selector. And then essentially .next means get the next one, and because we haven't iterated over this at all, next is essentially like getting the first title that we find, and because there should only ever be one of these, it will just get whichever one exists, right? So assuming this works, we have a wrapped version of the title. We double check to see if it worked, so we check if it's none. If it is, then we just move on to the next element. If it's not, then we go ahead and unwrap the title and store it in another string literal. Now came the next part. I had to check, is the game DLC? I had a couple issues with this. I figured out the problem. Took me a little bit of time. Wasn't used to this kind of issue. So the issue I had initially with the application was, instead of having this nice short list here, Borderlands would have a list of like 45 different items, because a lot of these games is DLC, right? So you get a lot of DLC in the results. So I was like, that's not going to do. I need to get rid of the DLC. So I made a function. The DLC gets app ID, another string reference to a string literal, and it returns a boolean, or another error if it errors out. And it's part of the result, so you have to unwrap it again once you're done. Once again, very good for error catching. Anyways, what we do here is, this is the API call that I was talking about. I could not for the life of me find this, so I had to do some digging, and then I found the API call. Okay, so we go ahead and open that up. Then let me grab an app ID. Whoops. Yeah, throw in an app ID. This essentially gets us back JSON data. Very useful. So what we're doing here is we're just creating another URL with the base of that, and then we're just pushing the app ID to the end of that string. Okay, simple as. We build our HTTP client again, and we just essentially send for a GET request and return that data, but this time instead of getting it as a text, we get it as JSON, okay, using the glory of Serde JSON. Although, to be frank, it's technically request JSON, but I believe request uses Serde, so it's still Serde JSON. Anyways, moving on. So, what do we do? So, how can we determine if it's DLC or not? Well, for that, I'm going to need to actually demonstrate with some DLC. For a start, we can see we have type up here. Type is game, okay? So what we want to do is we want to make sure this is game, because if we go to something else like DLC, say for instance, whoops, I did not mean to do that, I didn't want to click on it, although to be frank I would have still got the app ID from that, but it is what it is. I'll just grab it from here, I'm already here. Oh, my touchpad's on. I'll have to turn that off soonish. I absolutely hate the touchpad being on. Anyways, if we go here, we see that we have our app ID, which is the first one in the JSON file. Technically speaking, we can actually get multiple at a time. I think that might be a way that I can optimize this, so I'm definitely going to have to look into doing that, because you can specify multiple app IDs. If I did, I believe it's comma, and I can then go to, say here, I'm just going to do this, it's a bit easier, and then, oops, then I'm pretty sure I can do that. Oh, no, not how that works. Maybe it's like this. Okay. I have to wonder how that's what separator they use for that then. I'll figure that out another time. But I'm sure they use some interesting separator for this. Anyways, I'll get onto that. But I'm pretty sure I can optimize by just passing multiple app IDs through here. Just not sure how to do it yet. Anyways, so we have our type of DLC here. We don't want that. We don't want DLCs appearing, okay? Plain and true. So we want to create a mutable variable again, a boolean, and we're going to set it equal to false by default. And then we're going to get the app type, which would just be our response, which is a JSON variable, or so they value, as it's known. Value is just essentially a JSON value, any valid JSON value. Then we want to look at the node of app ID, which is this up here. And then we want to look into data, which is here. And then we want to look at type, which is here. And then we're going to pass that string. Because of the way ownership and stuff like that works in Rust, if I didn't do .clone, we would have an error because it does not implement the copy trait. we can't just simply copy. I'm pretty sure I can't even borrow it, can I? Oh, I didn't even need to clone it. I could just borrow it. Yeah, that makes more sense. Yeah. Yeah, it makes significantly more sense. Huh. No way. It doesn't return a different type, does it? Oh, I'm still... Yeah, no, it doesn't even return a different type. I may as well just pass a reference to that then. That's a lot better than cloning it. Cloning it is not needed. So yeah, I can just pass a reference then. That's another update there. Much simpler. Probably saves on RAM as well, I'm pretty sure, because cloning would have to essentially double the RAM because I need to restore that data again. So yeah, that's good. I get to borrow it instead, which is much better. Anyways, so yeah, we just borrow that value. The way ownership works in Rust is a bit confusing. I'm not going to get into it because I'm only 2 weeks in. I should definitely comment some of this code as well. This is very fresh code. Anyways, so we get the app type. We check to see if it's not equal to game. If it isn't, then it must be DLC. So we set that to true, and then we just return is DLC, either true or false, right? Nice and simple, very easy. So anyways, back down to where were we again? Where am I? Ah, right. Yeah, it should be. Oh wait, yeah. No, I was on. Oh god, I'm getting confused now. I was on Get Games, wasn't I? Yeah, here it is. So yeah, we got our DLC. We made sure it's not errored out. If it is, and we just print couldn't determine if blah blah is DLC. I've never actually had this error out. The only time I did have that error out was when there was a bug in my code, but then I fixed that and it's perfectly fine. But if it does, we even print it as well, just because I want to make sure you know that we couldn't determine if that particular title was DLC or not. I would print the title, but I feel like there's no broke point. We may as well just say that they couldn't determine it and then leave it at that, and that's a problem I will fix at some point. Anyways, then we unwrap the isDLC wrapped variable, whoops, and we store it in isDLC, and that's going to be of type boolean, right? See, that's already, Rust is pretty cool. Rust is kind of like Python. It will interpret what type it should be, but you can also specify, so I could tell it it's a bool directly, well, not bool 2. I can tell it it's a boolean directly, or I could just, you know, not. Really my choice, but it's very cool that you have that kind of level of flexibility there, where you can just let it determine. There are some cases where you do have to explicitly tell it, like when I was doing that set a value thing, it wouldn't know to use set a value, I'd have to tell it to do that. Otherwise it does just error out. Anyways, we check to see if isDLC. That essentially means, you know, just like saying if it's equal to true, right? Except we don't need to do that. Once again, much like Python, we can just do that. Don't think Python's actually specifically on that. I'm pretty sure C# does that as well, if I remember rightly. Can't quite recall. I have to double check that in some of my code. Yeah, it gets confusing when you move around to different programming languages. You forget a couple of things. Like sometimes I'll start using semicolons in Python. It gets really awkward because no one likes semicolons in Python. You can technically use them, but you're an absolute outcast if you do. Anyways, so we check if it's DLC. If it is, and we just move on to the next element because we don't care about DLC. We are only after games. So then we create a mutable variable of a vector of strings, and that will be our particular game info for that element that we're looking at. And then we just simply push the title, and we get that from a string literal, and we convert it into a growable string, and then we obviously unwrap that data, and we do the same thing for app ID and push them both into that vector, right? So that will be at index 0, and that will be at index 1. Then we simply, I'm pretty sure, right, I can do, oh wait, no, I can't do that, because that would error out because it's looking for a non-reference. Yeah, I do need to clone this one. Yeah, don't worry. I was being silly. I do need to clone that. It's not looking for a reference to it. It's looking for it's looking for exactly that. I could do references, maybe. Because I'm in a for loop, that reference would die though, wouldn't it? So I couldn't do a reference. No, I have to clone it, yeah. Yeah, no, I have to. Because otherwise on the next iteration, that reference would be dead. So it wouldn't. It wouldn't have that information anymore, and it'd probably just panic. So not good. So we do have to clone that information, unfortunately, which does mean a bit more RAM usage, but I'm pretty sure we can live with that. To be frank, if we were storing it as references, we'd have to store it in another list anyways, just a reference from that list, so it'd be completely redundant. Anyways, so we just essentially push that vector of strings to our games list, right? And then simple as, we just iterate through all the elements and do all that and repeat, and then we just return our list of games, right, using the OK method. You can also return error as well if you errored out. I don't know how you do that for results. I know you can do that when you're using match, but I haven't really gotten into match properly yet. That's something I need to look into. It's pretty neat for error catching, I'm not gonna lie. So I will definitely have to look into utilizing match. But anyways, for now, I'm not. So it is pretty basic. That's how we get our games list. Nice and simple. Easy peasy. So here we just create a temporary list using the reference of our games list. I had to do this because of some interesting stuff with moved values and stuff like that. It was, yeah, ownership on Rust is a bit complicated, but once you got the hang of it, it's so much better than anything else, because you just don't get errors, really. You don't get any problems. There's no headache like you get in C++. So, you know, this is a very low level compilable language. It's like C++, not quite as fast, but still insanely fast, and it's memory safe. Like, what more could you ask for? C++ is a nightmare to work with. Rust is so much better, and because you have things like the Rust analyzer as well, you can see that running down there. I can see errors in real time. C++, there's a lot of errors you won't see coming. You'll just get a seg fault and be absolutely confused, and then have to use like GDB to try and reverse engineer your code and figure out what on earth went wrong and do a whole stack trace, and it's painful. It gives me nightmares just thinking about it. So yeah, Rust much better for that. Anyways, moving on. We got a temporary list. We create a counter as well because we want to be able to print where we are in that list. I need to look for a more elegant way to do it. I know in Python you can just use the enumerate function, and then you would get return a tuple of the index that you're at as well as the data from that list. So in our case, a vector of strings. But I looked at the enumerate function on here, and it doesn't seem to work the same way as Python, so I'm going to have to look into that some more. But for now, I'm doing a little bit of a hacky old age solution of just creating a unsigned size. Usize is a really weird data type. I'm not 100% certain. Yeah, I'm not certain why this gets used, but I know it does when you're working with indexes and stuff, so I just use usize for now. Anyways, very useful for indexes, which is what I'm working with this vector, right? So anyways, we just count up that usize is unsigned, so it can never go below 0, so that means less error checking for us. The Rust compiler will already deal with that for us. Yeah, make sure that doesn't have an issue there. Although unless you run it in unsafe, then yes, you can very easily get overflows and underflows. So don't run your code in unsafe unless you really, really, really have to, which I'd strongly advise you don't, because you can cause a lot of problems for yourself running unsafe code. So definitely don't try that. Just try and fix your code. But sometimes it is required, unfortunately. Anyways, so we have a counter. We count up and we just print the current game title that we're at, as well as that. That prints us this nice little list you see here. So that way the user can determine what choice to get. I'm still not sure if I want to start this choice thing at 0, if I want to start it at 1. 0 just feels right to me, because the whole indexes thing, and plus it means I don't have to add 1 to it as well every time I display it on here, so it's less operations, and yeah, it's just slightly marginally faster by like milliseconds probably, if that. But you know, speed and optimization are very much like it. So anyways, we once again store an empty string for where our choice variable is. That will be our user's choice. So, you know, 0, 1, 2, 3, 4, 5, 6, 7, that kind of thing. And yeah, we do the same thing we did before. We just read from standard in and do that little command line prompt thing that you see here. You know, nice and simple. I've already gone over it. Yeah, more choices. Here we do something interesting though. We take the choice and we have to then, yeah, so here, this was the interesting thing I was on about. In Windows and Linux, line breaks are slightly different in the terminal. I noticed on Windows, the terminal uses /r for a line break, but in Linux it's /n. So I just have to essentially replace both of these line breaks with blank strings. Or blank characters, rather. Although it does count as a string literal, but realistically it should just be a character. It is what it is, right? But anyways, we replace it with a blank string literal. Simple as. After formatting the user's choice, we then attempt to convert said choice. By the way, another reason why we do this is because if I try to convert the choice without formatting it and getting rid of the line breaks, it would fail every time because the line breaks are there, and yeah, the .parse function doesn't look for line breaks apparently. It just passes it as is and hopes for the best. So I had to do that manually, is what it is. I would prefer it if .parse tried to get rid of those line breaks, but I guess it makes sense why they wouldn't do that in case you were trying to pass to something else, like, I don't know, a non-string literal? Or a string literal? I don't even know. In case you were trying to pass to something else that where a line break isn't an issue. I'm not even sure what. Bytes, maybe? I don't know. Either way. We convert that to usize by typecasting it to usize. See here, good old typecast. And then we check to see if that errored out trying that. And that if it errored out, it probably means that you didn't choose a number, or you've got a space in there somewhere, which I should probably also try and filter out as well. It's not too difficult. I'd just do something like .replace that with that. Simple as, and that would get rid of spaces as well. That's probably definitely essential. I mean, I haven't had any problems, but in case the user does do spaces, we can get rid of that as well. Very useful. Anyways, so we check to see if that's errored out. If it has, it probably means that you didn't input a number. You probably input in letters as well, so it couldn't convert it to a usize. If that's the case, then we just exit out the program. You know, we move on, and then we go ahead and unwrap that choice. And put it into choice int because it's now the int version of it, although technically it's a usize, which is an integer, but like a different data type for an integer, you know? Technically still an integer though, so the naming still works. Anyways, we throw it into choice int. And then we check to see if that is greater than or equal to the length of games list. The reason why we want to check if it's equal to the length of games list is because arrays start at 0. So if we only checked if it's greater than, then once we hit the value of the length of the games list, we would actually get an index out of bounds error and a crash. So we need to check to see if it's equal to as well. If that is the case, then we've clearly made an invalid choice. So we once again exit out the application by returning out of this function. There is also an exit function as well, but I prefer return. It's a lot cleaner. Sorry, a bit tired. Anyway, next we have game choice here. This is our we're going to be sorry. Our game choice is essentially actually more like game info. It's a vector of strings again from our games list, which is just a vector of strings, and we use the index of choice int from our previous choice, and we clone it. Although I will admit, I bet you I can probably just do a reference to this, right? So if I just did that, oh no, I can't. Expect types label, expected vex found reference. Yeah, that's a fair point. Actually, couldn't I just do that then? Yeah. I can just pass a reference, much better than cloning, more efficient, I believe. Yeah, it should be. Cloning would use a bit more RAM, I'm pretty sure. So anyways, yeah, we can just pass a reference to our choice. Pardon me. Anyways, so from then on, we now need to get our ProtonDB info, which requires another function. For this, we'll be passing through the app ID of our game choice. We then create our URL, which will be here. It's the ProtonDB API. I did find this myself, actually. Interestingly enough, if we go over to ProtonDB, we go here. Did I find it from 2 secs? Oh, hold up. Borderland. Oh, XHR. No, I didn't find it from here, did I? Oh no, I did. Yeah, reports, summaries, blah blah. Yeah. So as we can see here, when we do a little search here, we actually do API calls and we return JSON data, and then there's some fancy dancy code that takes that JSON data and essentially prints out this cool shiz here. But anyways, we can use this API calls, right? we just simply pass through our app ID and we put .json at the end, and we can get the response of JSON here, which gets us our best reported tier, the confidence, of how good that score is, and blah blah. I've already gone over all this. Very neat. Tier, total users, and trending tier, which is very useful. Already gone over it, as I said. Very good. So what we do here is we just create our base URL from this string literal here for the API for the report summaries. Report summaries, just a summary of all the reports and what that information tells us. And we essentially just push our app ID and we push .json to the end of it as well. Then we go here, we build our HTTP client, we get the response as JSON, and then we just return that JSON data. Don't need to do anything fancy with it or anything like that really. And then from that JSON data, after we pass through our app ID as a reference, bloody insect, we then check to see if it errored out. If it did, then we clearly failed to retrieve ProtonDB information, so then we quit out of the application again. Here we then grab that ProtonDB information and unwrap it from our wrapped ProtonDB info. We then clear the screen again and we print out the info. Just simply using, the JSON stuff again. We get the best reported tier, the tier, trending tier, total score, and confidence. Simple, simple, simple. This is print line. This is a macro. Macros are really cool. I need to figure out how to use them properly, but they are really neat. I do love macros in Rust. This allows us to essentially pass a string literal and have these brackets in here, which allows us to then pass a couple arguments here, which allows us to format the string literal quite nicely. I don't know how you do that outside of print line. I do need to look into that as well. I know Python had a dot format, and you can also do f strings as well. I don't believe f strings exist in Rust, not as far as I'm aware. I'll have to double check that. So I have to find some interesting way of doing that. That isn't just constantly pushing stuff to a string like I've been doing before. Anyways, I digress. This is a very simple application, very basic. One final note I want to say is if you want to compile it for yourself, if you're on Linux, you can just do the simple cargo build tac release, and that will build it and release it for you. I say release it, quote unquote. It will create a release build for it, which is what you would definitely want. You don't want a debug build. You want all the optimizations of a release build, preferably. Just wait for that to build. I've then got another way of building this. I was doing some digging because I wasn't sure how to do cross compilation, and I found a very cool application called Cross. But first off, let me just show you where that's stored. So if we go an ls into target, we will see the release folder. And if we go into release, we see that protondb.lookup is there. So we can just simply do /target release and protondb lookup, and boom, that runs protondb lookup, and we can do borderland. Should I put an S there, but whatever. And that'll simply do our search. I definitely need to find ways to speed this up and improve the not compile times, the run time for this. But I feel like some of my limitations might just be Steam, and yeah, just Steam really slowing me down, limiting the amount of requests that I can do, which is fair enough. I understand that. Anyways, yep, nice and simple, runs well. So you're probably wondering, how do I build this on Windows? Well, I don't know why you would want to, but here's how you do it. You just simply, what I do is I use an application called Cross, and I build using that. I'm pretty sure you can also do, hold up, pretty sure if I replace that with cargo, can I build it with cargo as well? Yeah. You can also use cargo for this as well. I use Cross because it runs a bunch of stuff in Docker, which is meant to help out quite a bit with cross compilation. I haven't actually tested if this works just using cargo, but I know for a fact Cross works. So if you do want to cross compile this, that is a good way to do it. From Linux, at least. If you're on Windows, you can still just do cargo build and tac release. Yeah, see, the link wasn't found. Yeah, so if you're on Linux, you need to use Cross. That will build it as a release version. If you're on Windows, you can just do cargo build tac release, and that should build it for your operating system. Rust should just, well, Cargo should automatically detect your operating system and build for that. Fairly simple, right? But anyways, that's pretty much all I need to show. I'm kind of curious now, actually. I'm going to quickly test this. I'm kind of curious to see if this actually runs in wine. Last time I tried it didn't. We had some failures, but I found out it was just a wine incompatibility thing. If I just go to wine target and what is it, x86 release print db lookup exe. What else did it have there? Not sure what a .d is. Yeah, not sure on that one. Oh yeah, okay. Hold up, this might actually work. Yeah, ignore all that wine stuff there from things breaking. Wait a sec though. That should hopefully work. I don't see any reason why it wouldn't. All this stuff should work in wine. But maybe not. Ooh. Oh no, I don't think that's working. Yeah, no, my network's... Yeah, you can see down there, the network's not going or anything. Yeah, no, that's dead. Alright, fair enough. Doesn't quite work through wine. That's a shame. I would like that to work through wine. It's much easier for testing. Anyways, that's pretty much how you build this application. If you want to go ahead and check it out, please do on my GitHub page. And if you want to check out other Rust projects, I've been looking at rustprojects.com. Do check this out. It's very cool. I very much like Imager. Imager is a very cool project I was just looking at. Its compression benchmarks are pretty damn good, I'm not going to lie. So if you want to compress a batch amount of images, definitely check out Imager. Very cool application. Very, very cool. But otherwise, that's me done for today. And yeah, I guess I'll be seeing you guys later. I hope you enjoyed the video. Oh god, I don't want you looking at that. That's not nice. Anyways, I hope you enjoyed the video. I hope it was insightful, and hopefully this wasn't too long. How long I've been doing this for? I swear there's meant to be a timer somewhere down here. Oh, 52 minutes. How? That's meant... This is 193 line. How did I do this in 50? Okay, I blabbed too much. Well, I'm terribly sorry for the blabbing. I will definitely... Yeah, this is definitely just long-form content. My bad. I like to go over every inch of my code. I'm very much a person that likes to explain how things work. I like to know how things work, so yeah, forgive me. Anyways, I hope you enjoyed the video, and I'll be seeing you guys another time with another project, more than likely. Also, if you're wondering, will there be a graphical user interface for this? I might see if there's Qt bindings for Rust. If there is, then yes, I can make a Qt application in Rust. That's not a bad idea, actually. Qt is cross-compatible, so that should work with Windows as well. And Mac OS as well, I'm pretty sure. Not that, once again, you need this software on Mac OS or Windows, but if you want it, it will be there. I like the idea of having options, so I very much like to give people options. If you want to know more about my operating system as well, feel free to ask. I can do a video on my i3 configuration, which is what I'm using as a desktop environment on Linux. And yeah, I can go over all that if you want as well. I'm very much big into the whole tiling window manager, as you can see here. Very big into the tiling window manager scene and just customizing your desktop to fit your needs. It's very nice. Oh, clock, you do annoy me. Beautiful sounds. Anyways, I hope you enjoyed. Catch you in a bit.